Okay, looking at chain rule for differentiation. This is for ones where we've got a power, a function, and a power on the outside. Previously, we've multiplied them out, but if we start getting powers, like one of my examples, a power of 6, you'll be there all day multiplying it out. There must be a quicker way of doing it, and of course there is. So we don't have to multiply it out. So previously, we've done power down, multiply, reduce the power by 1. With chain rules, a slightly different thing. What we do is we bring the power down and multiply. We write down what's in the bracket. We reduce the power by 1, but don't forget to times by the differential of what's in the bracket. So here, you bring your power down at the front, multiply. You write down what was in the bracket. You reduce that power by 1, and you times by the differential of what's in the bracket. In this case, a. If it happened to be a squared, it would be 2a. If it happened to be a cubed, it would be 3a. 3ax squared would be multiplied. And you'll see that when we go through. So overall, we get an bracket ax plus b to the n minus 1. So looking at the first one, differentiate x minus 4 to the power of 6. So power down, multiply. Write down what's in the bracket, reduce the power by 1. Then you forget to times by the differential what's in the bracket, in this case 1. So we multiply by 1, we're just left with that. So it's 6 brackets x minus 4 to the power of 5. Much quicker than having to multiply it out. Similarly here, 4x plus 7 to the power of 3. So we bring the power down and multiply. We write down what's in the bracket. We reduce the power by 1, but don't forget to times by the differential of what's in the bracket. The differential in the bracket, 4x plus 7 equals 4. So 3 4s are 12. The bracket 4x plus 7 squared. What happens when we get something like this one? So we've got root x plus 3. We can put that into that form where it's power form. So power down, multiply. Write down what's in the bracket. Reduce the power by 1. Don't forget to times by the differential of what's in the bracket. When we differentiate that, we get x. So it's just a half x plus 3 to the negative a half, which is 1 over 2 square root x plus 3. For the third one here, we've got y equals 1 over 3x squared minus 2. So put it in power form, 3x minus 2, 3x squared minus 2, all to the power of negative 1. We bring the power down and multiply. We write down what's in the bracket. We reduce the power by 1, and we don't forget to times by the differential of what's in the bracket. So the differential of 3x squared minus 2 is 6x. So multiplying this, we get negative 6x, bracket 3x minus 2 to the negative 2. So popping that underneath, negative 6x over 3x squared minus 2 all squared. So now looking at it with some trig. So this is actually what you're given on the formula sheet when you look at the differentials. So sine of ax is a cos ax. The a is kind of the bit in the power. The sine is there other than the power. Our power functions, this is a sine function. So this is the power down multiply bit. So we change our trig. Don't forget to times by the differential what's in the bracket. So sine becomes cos. The differential of ax is a. So it's a cos ax. Here, cos becomes negative sine. The ax differential of a is a. Sorry, ax is a. So cos is negative sine. So it's negative a sine ax. So what we're looking at here realistically is sine becomes cos. So it's cos ax times by the differential of what's in the bracket. So I've just kind of gone through. You're given this in the formula sheet without that explanation. So looking at the first one, sine 3x, sine becomes cos, so cos 3x. Then you forget to differentiate, times by the differential that's in the bracket. So 3x will be 3, so it's 3 cos x. Here, cos bracket x minus 1 minus 4x. Cos becomes negative sine. You still get the same angle. Don't forget to times by the differential what's in the bracket. So the differential of that's 4. So negative, negative, positive 4 sine bracket x minus 4. Gets slightly more complicated when you've got powers. So x cubed is actually sine x all cubed. So here, power down, multiply, write down what's in the bracket, reduce the power by 1. Then you forget to times by the differential of what's in the bracket. We don't have a value in front of the x, so sine just becomes cos. So it's 3 sine squared x cos x. Slightly trickier one because we've got a double bit here. So f of x equals 2 over square root cos 2x. So putting it in differentiable form, 2 cos 2x to the power of negative a half. So power down and multiply, so 2 times negative a half. Cos 2x to the power, reduce the power by 1. Don't forget to times by the differential of what's in the bracket. So the differential of cos 2x is negative sine 2x, but don't forget to times by the differential of what's in the bracket. So differential of 2x is 2. So you've got a negative negative, so it's positive 2 sine 2x over square root cos 2x cubed.